and welcome to Pre-Calculus for Business with Professor Checo. Today is our last lesson, lesson 8.5, the random variable, probability distribution, and the expected value. All right, let's get into it. 20 questions, not too bad. All right, for the following set of numbers, find the mean. You add them all up, divide by the number of items you have. So here, 1, 2, 3, 4, 5, 6, 7. Add them up, divide by 7. Done. Find the average mean, which is the same exact thing, if each score is multiplied by 2. Multiply by 2, by 2, by 2, by 2, add it up, divide by 1, 2, 3, 4, 5, done. So here, xi is your number and it's the probability. So e of x should be 1. Review the definition of the expected value. The expected value here... Oh, wait, what am I doing? I should be reading the textbook. My mistake. All right, let's get into it. So the random variable. A random variable is a function that assigns a numerical value to each simple event in a sample space. So here, if you're looking at 3 coins, boom, number of heads, whatever. So that's your random variable. You can turn it into a histogram. Probability distribution should be between 0 and 1, and all the probabilities have to add up to 1. The expected value is you multiply each of these times that. That's what it was. Got it. Steps for computing the expected value of a random variable is you just multiply the probability distribution by each random variable and add it all up. Blah, 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 moving on, moving on, moving on, moving on, moving on. I just see a bunch of stuff that we've already done and stuff that we've already done. Decision making and expected value, so forth. All right. So here, what I need to do is multiply -3 times 0.4, 2 times 0.4, and 5 times 0.2, add it all up, and then get my answer. So let's see. Do I still have Desmos open? Yes, I do. Let's get into it. We're going to do -3 times 0.4 plus 2 times 0.4 plus 5 times 0.2, which gives me 0.6. So my answer here, my expected value is 0.6. Awesome. So here, you draw this from a bill from a hat that contains 5, 10, 20, and 100. What's the expected value of the game? Isn't this just 0.2, 2, 4, this 4, 2, 5, 0.25, or simplified fractions, 1/4? 1 out of 4, 1 out of 4, 1 out of 4. Nice. The expected value of this game is you multiply 0.4 times 5, 0.25 times all of these added up, and you get your value. Yep. Here you have 6 pennies, 1 dime, 43 quarters. Each of these have sorry, have a value, so you would add them all up and then figure out what your expected value is. Now remember, 6, 1, so 7, so then you have 50 coins in general, so understand that this would each be double, so this would be a 0.12%, this would be a 0.2, and this would be 83% of happening. And you just multiply it all, add it up. So let me see if I can do it in Desmos real quick. So let's do 0.12 times 1 times 0.01 plus 0.2 times 0.1, a dime is worth 10, plus 0.86 times 0.25. So my expected value is 23.236. 0.236. Oh, round to 3 decimal places doesn't need. What is the expected value? Where did I mess up? I must have done something ever so slightly wrong. 6 pennies. Oh, 0.02. There it is. There we go. See? Next question. 52 dart deck. If you win, it's $5. Otherwise, you get nothing. What's the expected value? So that's 2.5 because it's half times 5, a half times 0. Add them together. Done. If you're tossing 5 fair coins, what's the expected number of heads? 5 times a half, 2.5. 5 over 2. Type in an integer or a decimal. So 2.5. You multiply the probability times that. See, an unfair coin is tripped if it's heads up, you win $1. If it's tails up, you lose $1. Probability of getting heads is that. Probability of tails. What's the expected value of the game? 0.62 times 1 is 0.62, and this probability is 0.38. What's your expected value? Multiply them two, add them together. It's going to be something. You guys got it. After paying $2 to play, a single fair coin is rolled, and if you are paid back, the number that corresponds to the number of dots facing up. For example, if a 3 times turns up, $3 returned to you for a net gain. Pay off $1 if 1 turns up and 1 is net gain. What's the expected value of the 0 of the game? So let's do this. There are 6, right? It's 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? No. It's negative 1 plus 0 plus 1 plus 2 plus 3 plus 4. And then this is going to be 1/6. Right? Because there's a sixth of chance to win. A sixth of a chance to win for each of them. I'm expected to win 1.5. Nice. Is the game fair? No, because you're expecting to lose 50 cents. Same exact thing. On 3 rolls of a game, you lose 12. If it's 5, if a 5 turns up, otherwise you win 7. Oh, so here this is just a little bit different because the probability of losing on a 5 is 3 out of 18, 1/6. Otherwise, you'll win. Can I do 15 out of 8? So is that 1/6? 5/6? Oh, I don't know what the fraction is of sixths. 0.17, or simplified fraction. So 1 divided by 6, comma 5 divided by 6. 5 divided by 6. What are the answers? Whoa. The expected value is easy, that you can get, but how do they get those numbers? Interesting. I'm gonna keep going. Let's see. A pair of fair dice is rolled once. Suppose that you lose $7 if the dice sum is to 10 and win $8 if the sum is 4 or 6. You should keep the gear fame. You would win. Oh, I have no idea. So going through this, probabilities. Yeah, it's kind of all in there. So there's your information on how to get it. Cool. Moving on. Let's see. A 5-card hand is dealt from a standard 52 deck. If the 5-card hand contains at least 1/6, you win $8. Otherwise, you lose $3. What's the expected value of the game? So 5 cards deck, at least 1/6. Find the probability of getting a 6. You multiply that by that, and otherwise you add it to that. View an example. It's there. It has all the work. Awesome. I'm gonna let you guys do that one. A payoff table for 2 course of action, A1 or A2, is given to the right. Which of the 2 actions will produce the largest expected value? Action A1 or A2? Probably A1. I don't know. You just type that, you multiply all that in, and you're gonna get some answer. It's probably like $50. I don't know. Oh, you're expecting $200. Nice. All right, you guys see how I did that? It's easy. All right, probability of winning. Would you play this game? A game has expected value of for you for $200,000. It costs $2,000 to play, but if you win, you receive $10,000. 100%. No, not 100%. One. No, it's um. The game has expected value to you of 2,000. It costs $2,000 to play, but if you win, you receive. Why is it 0.04? I mean, that just makes sense, but I don't know how they got 0.04. 2,000 out of 100? I'm not sure. Moving on. 5,000 tickets are sold at $1 each for a charity rifle. Tickets are to be drawn at random and monetary prizes awarded as follows. One prize, 800, three prizes, boom, boom, boom. What is the expected value of this raffle if you buy one ticket? Give you an example. Is everything there? Yep. Boom, boom, boom. Going through everything. Yep, it's all there. And then you get the final price. View an example. Cool. Same exact thing. View an examples there. You guys are good. After carefully testing analysis, an oil company is considering drilling in two different sites. Its estimated site with net cost of boom will lose $3 million. If not, what is the company should it pick? View an example is there. They find the expected value. Good to go. Oh, another one with a view an example. So the expected number of boys in a three-family thing. You find all the probabilities. You multiply them, and boom, boom, boom. Just work through it. Cool. And last question: a pink flowering plant. What's the expected number of W genes presented at the crossing of this type? Multiply it out, view an example, boom, 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 and you're good to go. And that is the last chapter, 8.5 random variable. All right, best of luck, guys.